Howdy, hey, I'm Brett, Use4 Aircraft. Today I want to show you how to build the FPV Simple Plank using our 3D printed templates. Let me show you this. Standing at the bed of my laser cutter. This is something I was fortunate enough to end up with because I got an understanding wife and poor impulse control. What you see here is a sheet of Adams foam board, 20 by 30, standard size. Comes in the boxes like everybody sees, just like that. Anyway, laid out on top of this are the 3D printing components. Let's go ahead and show you some of those. This is the fuselage template. The fuselage template, as you can see, lays perfectly over the actual cut fuselage as shown on the laser cutter. The fuselage template is 3 parts. It's designed this way so it can print in a 200 millimeter by 200 millimeter 3D printer, which is a pretty standard size 3D printer bed. So again, take the pieces out. I've just taped them together, and that's what you end up with. A solid template that again will allow you to cut the fuselage is shown there. The wing template is similar. It too is printed in 2 pieces. As you can see, folds over just like that. Each one of these pieces, same thing, under 200 millimeters, and allows you to print this, which will then let you cut that. The wing itself consists by and large of straight lines. So when you place this in the center of your wing and you begin to make your cuts, you can simply extend the fold line all the way to the tip of the wing, and same thing with the elevon hinge lines all the way to the tip of the wing. The length of the wing is entirely up to you. I've seen guys make them longer, and I've seen guys make them shorter. As I'm going to build it today, and to show you on a standard Adams foam board sheet, here's a ruler. This is a 550 millimeter wingspan. So the other parts, this is your rudder, same thing. There's the 3D printed template. Underneath is the actual part we're using. This is the forward vent latch and closeout. It's where you mount your FPV camera. This is the actual nose of the aircraft, which again the camera will use in order to stabilize itself. This is the tail and the rudder mount and the tail closeout and fuselage reinforcement. I'm going to pull these parts out, put them on the work surface, and let's get to work building an airplane. Okay, these are the foam board pieces that we're going to be building with. And again, in no particular order, the rudder, the nose vent and camera mount, nose closeout, rudder mount, aft tail closeout, fuselage doubler, fuselage, and the wing. Additionally, we're going to be using some electronics. Let's go over what I'm going to be building today. Today I'm going to be building an airplane to be used as a line of sight trainer. Yes, this airplane can be built as a flight controller equipped aircraft. It can be built with a DJI FPV-03 system. However, today I've got someone who's interested in learning how to fly. And before they start off flying with anything FPV, I start them off line of sight. So this is my replacement camera that I use. Same weight, same center of gravity properties, same mount system as the DJI FPV-03. But as opposed to risking a $180 camera system, it's a lot easier to crash with a 3D printed duplicate. So the electronics that we'll install are pretty simple. We have the motor and ESC. Here, I'll bring you closer with this. Motor and ESC. 3D printed mount incorporates the ESC on top, keeps it in the cooling airflow. There's the motor. The motor is a 2205, 2300 kV motor, standard quad motor for a 250 size quadcopter. It's nice. You can buy these motors relatively cheap. They use a pretty generic 6045 propeller, 6-inch diameter, 4.5-inch pitch, and provide power. Stand corrected. There is no power, as there is no BEC, no battery eliminator circuit. By that, you can tell, as there's only 2 wires coming, which is a ground wire and a signal wire. Power today will be coming to our receiver via a separate battery eliminator circuit. You can see I have that just wired into this intermediate adapter that I'm using. as a lot of my avionics are recycled and reused in other airplanes. The receiver I'll be using today is this Beta FPV ELRS PWN receiver and a pair of 9-gram servos that we'll be using to put the flight controls together with. Anyway, the avionics have been tested. They're bound to the receiver. Everything's been bench checked. The motor spins, ESC's working, BSC's putting out plenty of power, and the servo's been centered or in good shape. So let's go ahead using that for our avionics and get into the build. I like to clear my workbench. So in order to do that, let's start with the parts that are going to basically involve the most pieces. Move you down to the work surface. Show you what I'm talking about. All these avionics, put those off to the side for now. We'll grab our fuselage. And our fuselage is going to need the fuselage doubler, which will be mounted in the aft end, and the aft fuselage closeout. So first off, we need to bear in mind, bring it down here so you can have a better look. These are fold lines, here, here, and here. These fold lines are simply semi-scored. I use the laser, however you can also use an X-Acto knife. They're just not cut all the way through. The upside of these fold lines is they allow me to take a piece of foam board and do this. Bring it over to my table edge. Place the fold line on the edge of the table. And that's it. I create my fuselage brakes. This allows me to taper the tail of the fuselage in for the motor mount and a more streamlined design. Next, we're going to do the same with these longitudinal fold lines. Here we go. Same thing, put the fold line at the edge of the table. Gentle brake. Flip it over to the other side. Fold line at the edge of the table. Gentle brake. There we are. Now, move you back, bring you up a little. There we are. We have our fuselage. As you can get an idea, the tail will form like this. The aft end of the fuselage will form by tapering the fuselage, both the lower skin up and the two side skins in. So I'm going to use some maker's blocks. What are maker's blocks? These are them. They're also called 1, 2, 3 blocks or ABC blocks. Why are they called 1, 2, 3? This is 1 inch. This is 2 inch. This is 3 inch. So these are pretty handy. I like them because they allow me to jig up any of my aircraft and keep things square. Square to the work surface and easy to work on. So what we're going to do now is we're going to hot glue the tail. Let's show you that. Coming back here, and you can see about 3 or 4 inches forward is where I want to start my trail of hot glue. Let's move things around, see if you can watch. Grab my hot glue gun, and again, come back 3 or 4 inches. And just like that. Squeeze the fuselage sides in. Brace it up, and I'll use a couple of my 1, 2, 3 blocks. Hold that in place. If you don't have 1, 2, 3 blocks, use your hands. Use books, use any sort of material that you feel hold in position, or just don't worry about it. I mean, honestly, you can just hold these in place. That's the way I built the first couple hundred of these airplanes at least. I've been doing foam board airplanes for a while. I'm not the best at it. There's a million people that build them better than me. There's guys that are building airplanes that they feel look far more realistic. That's not my jive. What do I like? I like airplanes that build quick and fly well. And that's exactly what these guys do. So again, I just put a little extra hot glue along the interior seams there in order to make sure that that is a nice secure fit. This is the fuselage doubler. What I'm going to do, these fold lines here, let's go ahead and just break those. Just like that, just like that. There we go. The fuselage doubler is going to go inside here on either side of our aft fuselage taper line. Yes, this piece just fits in, as you can see, and then a little bit of hot glue in there to hold it secure. The purpose of the fuselage doubler is to reinforce the fuselage at the aft bend line, just like that. And also it allows us to, if we want to, separate high current, low current wiring with perhaps high current wiring running underneath the doubler and lower current wiring or antennas on top of the doubler. So again, this helps. As you can see, there is glue both forward and aft of these two fold lines here, and that will help to keep the tail on in the event of a hard landing or a shock. I also recommend you can run a bead of hot glue along the outside, because remember, anywhere where you have cut 2/3 of the way through the foam board, obviously the foam board will be weakened by doing so. So again, there's an idea of where the doubler is, and here you can see the foam board cut lines. So that has that in place. At this point, glue should be more or less cured to the back. We can put our aft tail. This is the motor mount and the closeout back here. Again, I'll bring the camera, get an idea where it is there. Put it in position, give you an idea where the hot glue should go. Little bead of hot glue. Little bead of hot glue. And that just sits in place like this. You know, in subsequent designs, there's been some considerations where this can be removed. And it is true. You can't always chase a lower parts count. But in this case, I found that the plane build's very easy, and this helps me solve some of my wiring dilemmas later. You'll see what I mean. I'm just, again, jigging this up with 1, 2, 3 blocks. That's what I love about these things. As you can see, this is holding the fuselage down so it's not sliding forward and aft. This is holding the two sidewalls in exactly the way that I want it. This block at the back is not touching anything, but it's allowing this block to provide pressure just on top in order to hold that aft fuselage closeout piece in exactly the position that I want. You know, I can then go on and start working on other things or other parts of the airplanes. Nothing's going to move, and we're in good shape. So what I'll do, let's go ahead and start putting some avionics in. Showed you the mess of avionics. Disconnect everything from the receiver. There's a close-up. That's what I'm using. It's the Beta FPV ELRS PWM receiver. I really like those guys. All in one, great little unit. My servos, these are just Metal Gear 9-gram servos. I picked mine up off Amazon, relatively inexpensive. Build a lot of airplanes, like to have some fun, not afraid to throw them out when they crash and die, and I find good bang for the buck. Anyway, these are going to go in the servo cutouts. Servo cutouts be just under the wings. I always run my servo wire coming forward, so installation, just to show you the other way, would be just like this. Same thing, I'm going to want to make sure I'll put a bead of hot glue on the bottom, place my servos in, and then we'll probably go ahead and jig this up using the 1, 2, 3 blocks to make sure that everything is held in position as the servos dry in place. So what I'll do, I can remove off the tail of the airplane the 1, 2, 3 blocks. I'll show you that. I'll pull these out. Feel that? Yep, that's secure. We're going to bring the fuselage flat again. And I'll take my servos, hot glue, run a bead just like that, run a bead just like that, servo wire facing forward, put that into place. Servo wire facing forward, put that into place. Now, don't have to do this, you can just hold them by hand. I'm going to put a pair of 1, 2, 3 blocks. And same thing, 1, 2, 3 blocks on top just to hold those. And again, this just makes sure everything stays exactly where I want it. You can see the fuselage is staying nice and square, and those servos are being held down, and everything's in position. So, again, I'm trying to reduce the amount of loose parts. So let's go ahead and take, this is our ESC as mounted to the motor and the motor mount. And the motor mount, if you notice, has these holes here and here. That's the underside of the ESC. And where this is going to sit is just back on top of this piece as such. These holes are designed so you can take the hot glue gun and put the tip of the hot glue gun right in there. And there's a star pattern on the backside. I don't know if you can see that inside there. That might be tough, but it'll be easier to see on the 3D print. And the hot glue will then flow through the hole along the star pattern and squeeze out through these perimeter holes shown here. perimeter holes shown there. So again, it's just a secure way of making sure that the motor mount is installed and mounted and stays in position. So this guy, again, we'll dry fit it, we'll test fit. Let's bring you back, show you from there. This guy's just going to go just like that. So what we'll do, a little bit of hot glue. Hot glue. A little coming down the back. And press our motor mount in place. That ESC is held loosely in there, and I want airflow on the top and the bottom, so it's not really held super tight. I got a little extra hot glue on there. You know what? Just going to wipe it off using my fingers. Wipe it, roll it. It doesn't hurt. You're in good shape. There we go. Nice and clean. Now, to do the kiss with the hot glue gun like I talked about, keep an eye on this. Hot glue gun goes in the hole just like that. Trigger squeeze. There it goes, just popping out. And add a little more hot glue here. My hot glue gun. Same thing. See if I can put you in a better position. Just like that. There we are. And it just started coming out the holes. Might be difficult to see. You're seeing a tiny amounts of a small clear fluid, but anyway, suffice to say, that'll work. Make sure the motor mount is being held square on top and flush on the sides. That the back of the motor mount is resting at the aft line of the fuselage. In doing so, there'll be a slight angle of instance where the thrust line is pointed up towards the center of the wing. And the reason being is that's to reduce pitch power coupling, high power settings, so you don't get unusual pitch commands with power application or powering off. Okay, talk about some of the wiring. As we said, I'm going to run my higher current wiring on the underside of the fuselage doubler, and I'll come back and show you this in a moment. And then the lower current wiring I'll have on the top. You know, as you build things in the future, it's not a bad idea to think about, you know, how you want to have your wires organized. So anyway, now I'll take my ESC, and this is, I don't get deep into wiring. Why? You can build this airplane with a flight controller. Matter of fact, here's a flight controller I'm about to harvest out of one of these airplanes. And I'll show you. I mean, that's one of my standard flight control board mounts. And the wiring can be as simple or as complex as you want. The airplane itself is not as sensitive to weight. What it is extremely sensitive to is center of gravity. So for a training airplane, I want to keep this simple. I don't want anybody to get distracted with flight controllers, the dynamics involved in how the flight controllers fly the airplane versus how the pilot flies the airplane. I want him to focus strictly on flying the airplane himself. So this is going to be strictly a radio-controlled airplane. So here we go. I'm going to take my, this is the servos, or I'm sorry, the ESC's signal cable, and I'm going to plug that and again do this however you choose to do it in a channel 1. I plug then my left-hand flight control servo, this is left-hand Elevon servo, into the next available channel, which that'll be channel 2 in this case, and my right hand into channel 3. I use the same numbering system or convention that we use in full-scale aviation, so everything on the left side is a lower number than the stuff on the right side. So anyway, the net effect is, there you have it. We now have a receiver wired up. Decide how I want to mount this. I'm going to have the antenna coming out here, so that'll be good. So I'll put just a dab of hot glue down there. Sometimes the best laid plans come victim to shorter power wires than you expect. Go ahead and mount this guy here. There we are. I don't build everything perfect, but We build them good. Good enough. Take away my 1, 2, 3 blocks. Here we go. Let me show you. This is where we're at. I ended up putting my receiver here. My antenna is going to come up and just rest up here on the upper surface of the fuselage doubler. So motor and ESC are back here. The rudder is going to come in here. The wing will be mounted here, obviously with the KFM step here. And then the vent latch will be here. And the forward closeout will be there. So let's go ahead and start closing things up at the back. Next fuselage piece that we'll use, I'm going to go ahead and install the tail closeout, and that'll press up just like this. We can get an idea where everything sits. I'm going to keep the wires out of the way of the where the rudder will pass through, and we'll do just like that. Put this on temporarily. Get an idea where you're going to have your hot glue, and the intent is the antenna will end up mounting here. Let's go ahead and run some hot glue. Came from here, about 10 centimeters forward of the aft fuselage taper line, all the way back. And again, try a dry fit. The measures I'm giving are just strictly off the top of my head as I'm looking at things. So that'll put that into place. Put this on like that. 1, 2, 3 block to hold it. Everything looks square. And that'll allow us to put the rudder in after we mount the wing. I typically don't put the rudder in until almost the very end. And the reason for that is the rudder will inhibit you from flipping this over and working on it when it's upside down. At the front of the rudder closeout, you can see this tiny little cutout here. And that's designed for the ELRS antenna. And what I can do is a tiny bit of hot glue, just there. Put my ELRS antenna coming up just like that. If I want to be lazy, a 1, 2, 3 block. Hold it in place just like that. And that'll cure. All right, let's move on to the wing. Put you up here. Feel if this is ready. Should be tacked up enough. Move the fuselage and the bulk of the parts out of the way. Next, we're going to do our wing. Shown here is the wing. Let me give you a tour. These here are a couple of marks that indicated on the fuselage template will be the center of gravity marks on the underside of the wing that put your fingers on a finished airplane, and as long as your center of gravity is there, you should be in proper CG in order to have a good flight. These are wing alignment marks. These will again protrude, be visible on the upper surface of the wing, and what they'll allow you to do is line up the center of the fuselage with the center of these wing alignment marks, and that way you know the forward edge of the fuselage is aligned and your airframe is going to be relatively square. So otherwise, this will be the wing fold line. This separates, allowing you to fold each side of the wing independently. And then back here we have our elevons, the hinge line here, and the hinge line here. These will be where the flight control horns go through, and we need to get on to building the wing. So let me show you how we do this. First, I need to introduce you to my foam board tool, available on the website. This is it. That's one end of it. That's a narrow hinge cutter that will allow you to cut hinges. Works pretty well. Opposite to that, and looking similar and covered with hot glue cobwebs, excuse me, is the wide cutter. The wide cutter compacts a little bit more material and allows you to cut foldovers. I really like these forming tools. They're my design. I came up with it, originally inspired by other people's tools that I saw them use in manipulating cardboard. However, what happened was the original tool, which I found off Thingiverse, I really think this is a brilliant design. Honestly, this guy's come up with a better interior axle, single piece print. This is a wonderful design. But if you notice, the scalloping, those teeth marks are aligned. Let me see if you can see it. On both sides, those teeth marks line up. So what ends up happening is that you remove the same material on either side of your fold. So when you try and make that fold, you have two, I guess it's convex surfaces trying to fold into each other. On mine, those scallop marks are offset, as you can see. So when you compress material here and compress material here, the inverted portion of that compressed, non-compressed area is allowed to fold into its foil, its opposite side. Either way, let me show you how it works. We're going to use the wide side. This is the wide side. It's about an 8mm wide, compression tool, and we're going to go ahead and run that along the wing fold line. I'll bring you down for that. I think you can see here, I'm starting at the far end on my line with the wide foam board tool, and I will run from one wingtip all the way across to the other, just using that line, that score line as a reference. Same thing, now we want to do these elevons. Elevons obviously back here. I like to run my elevons outboard in, and I will use not the wide tool, but instead I'll use the narrow tool. There you go. It's the exact same idea. It's just, I believe that's 5mm. So here we go. Place it down here, and I'm going to run along the hinge line, inboard, stopping at the cutout. I'm going to flip my wing around because I'm not as ambidextrous as I wish I was, and we'll do the same thing from the other side. There we go. So what we've done now, we have the wide fold here at the leading edge, and then we have the narrow indentations here, which will become the hinges. I can now take these two leading edge sections and fold them over independently. The way I do that, hot glue. There we go. Put down whatever pattern you want. A little in the hinge, perhaps. Not too hung up on it. Grab that leading edge, and in one motion, bring it over. Make sure your wingtips are relatively square, and I'll put some 1, 2, 3 blocks down on them. See that? Let's do the other side. Same thing. Even smear of hot glue. Not too terribly worried about the pattern, you just want to get good dispersion. Fold it over. Couple of 1, 2, 3 blocks. Hold these guys in place. There we are. While we're letting the that hot glue cool, let's back up here, flip you over here. I'll show you. These are the flight control horns that I use. You can see the flight control horns are connected by a sprue. Bear in mind, these are 3D printed. So that sprue is completely artificial. And despite the fact that it appears like they were born that way, they were not. These holes here, boom, 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 on the underside are designed so you can put next to the flight control cutout. I'll show you here. You can run a bead of hot glue on the outboard section. And by that, pointing at the pencil where I would run it, at the outboard section, a line of hot glue adjacent to the where the flight control horn will install, and then press the flight control through. So what we need to remember, these flight controls will extend to the undersurface of the wing from the top side. Right now we are looking at the bottom of the wing. So the servos will be here and here. So we can't install the flight controls while the wing is in this position. So let's go ahead and remove those 1, 2, 3 blocks. We'll flip the wing and put our flight control horns in. Here we go. Bring it down. Make your blocks off. Wing looks good. Kosher, kosher, bueno. Take these. I got a piece of foam board that's stuck in there. There we are. Clean out where my flight control horns are going to pass through. And again, remember, this is where the flight control horns are going to pass through. This is the upper surface of the wing. The flight control horns are designed, you can see the tab is extending out. I'm going to install it in the wing like this. And like this. And watch what I'm doing here. I'll bring it down. Do you see that? How I just have them hanging out in there? Watch. Take a line of hot glue. There you go. Same length as the cutout, but you can also put it in line with those dots. And in doing so, when I press this through, drop it into place, the hot glue will pop up through those holes. Kind of makes it almost like an old school Cherry Max rivet or something, an old school rivet holding those guys down. Now, through the magic of having more than one of these things hanging around, I can show you on another flight control horn. Do you notice these holes at the base? Here, here, here. When you put the control horn in, some of the glue will get in there and hopefully be stuck in the middle of the foam and help to adhere the flight control better to the elevon. This hole here, however, the larger hole, that's going to be exposed on the other side of the wing. So what we're going to do, I've given this a minute to cool, we're going to take the glue gun and the upper surface of the wing will be at a position like that, and we're going to squirt some hot glue through that hole. And what that's going to do is it's going to take that piece of foam board, and on one side, let me just make a for example. On one side, it's going to have the actual tab itself hanging out, and the other side, it's going to have hot glue passing through there. Again, now pinching the foam board. Because if you only glue the foam board on one side, what ends up happening is the paper works off the foam board, and if the paper worked off on this surface, the flight controls would deflect down, but would never deflect up because the paper would simply pull off the foam board. So, like I said, we'll flip it over. And we'll go into these holes, and I'll see if you can see this, and I'll squirt a little foam board through that center hole. There we go. And I'll do the same on this side, through that center hole. I don't know if you'll be able to pick this up, and it's a minute detail. But if you can see, just there, there's foam board on either side of those flight control horns. Do you see that? So again, those flight control horns are now essentially riveted into place. And yeah, look at that hinge line. Everybody says, wow, that hinge line, you know, is that looking rough? Again, the beauty of this is just basically how quickly it iterates. As you can see, that's a great little flight control. And what I kind of like about this is compared to a lot of other designs, you don't end up with goofy, weird creases if you've drawn your thing somewhat straight. It really keeps a clean look on the upper surface of the wing. So again, that's our, we now have our flight control horns mounted on our wing. All right, let's move on. Camera goes back up here. Flip you around, dial you down. We have our fuselage. We've already checked our avionics. We know these are good. I'm not going deep into the avionics with you guys on this. And the reason being is I expect you to have a basic understanding of how to put avionics into these airplanes. Whether you're using a flight controller or whatnot, make a decision whether you're closing out the airframe at this point. You know, it's just something you need to bear in mind. In order to test center of gravity, the center of gravity is denoted on the underside of the wings with these marks here. Those marks, you can see where they line up on the fuselage when you install. If you put your finger on the mark, as I'm doing now, and then remove the fuselage, or remove the wings from the fuselage, you can see it's about 60% of the way back from the leading edge of the KFM fold position. So if I put my battery in, and the battery will slide under the wing, and if I mount my camera, and yeah, sure, it's going horizontal, I can then pick the airframe up and get a rough idea of where my center of gravity lies. And what I can see here is that'll balance just fine. So get an idea where your center of gravity is, check your avionics installation before you close everything out. Easy enough to do. So what we're going to do now, we may as well go ahead and mount the wing onto the fuselage. So in order to do that, give myself some space. All right. Make sure there's nothing sticking up. None of your wires are sticking up. Everything is tucked inside. You've already done your avionics checkout. You know your electronics are good. You have your wing. You have the flight controls already mounted. Dry fit, get an idea. Okay, this is going to go here. That's how it's going to line up there. Look at the leading edge, and I'll let you take a look. I'll put this here so it doesn't rock back. And if we do things right, the trailing edge should line up as such. Coming forward to the leading edge, as you can see, those dots, and this is going to be hard to not parallax, should be straight over the fuselage sidewalls. And again, that means this wing is mounted correct. Okay, this is going to be a hard thing for you to capture. So see, look, you're just checking the tail end here to make sure that, again, all the lines line up. And then at front to make sure these dots are in the center of the foam board extending out either side. Okay, if you do that, you got a square airframe. What I'm going to do, bring it back, tilt you down, show you the work surface, pull this guy off. Let's hot glue it. When I hot glue it, start at the trailing edge. We're going to work all the way up to the cutout at the KFM step, all the way forward here. So I'll run a bead along the side rail, do a little donut over the servo, same thing, all the way up, forward cutout, fair amount of glue. There we are. Same thing. Do the same on this side. Good amount of glue there. On the back, coming forward, little donut over the servo. Boom, just like that. And now I'm going to bring my wing. I'm lining up the tail. Tail's in good place. And I'm lining up the front, making sure that we're in line with those wing cutouts. Make sure you press the wing all the way down and that it is actually sitting flush. And then I'm going to use my 1, 2, 3 blocks again because I'm fat and lazy. Hold these, and if you really want to be cognizant, you make sure the two sides and the leading edge of the wing are square. There we go. Now, we need to, I'll bring you around and let you look at this. Sorry about that. Okay, so there it is. This is optically aligned, but you can just see tail looks about right. And down at the front, you can see those dots are more or less aligned with the fuselage sidewalls. All right, let's bring you around here. Boom. Spin it. This is going to be the nose. We're going to install this. It obviously, oddball looking piece. What we need to do, is we need to bend this smaller section over so it's laying on top of the larger section. The way that we'll do that, come around here. We're bending 180 degrees, so I want my wide foam board tool. That's the narrow. This is the wide, okay? Wide foam board tool, and I'm just gonna run it along a line like this. Okay, that looks about right. See that? Crushed as set. You can see those offset depressions in the foam board. Run a little hot glue, just a tiny bit inside the center, and make silly patterns in the middle. Cool. I'm going to fold this guy over, and again, take a 1, 2, 3 block, put it on there, and I'm going to let that sit. Okay, that'll be the nose closeout. Let's do the, this is where the latch, which is a 3D printed part, looks like this, foam board latch. It allows airflow in. That airflow is pumped down through this and through this hole and into the fuselage. So if you want, I'll show you now, you make a tiny squeeze here and here, just at the trailing edge. And so the foam board latch can then slide in just like that. And now you see how the foam board latch works. See that? I like that. I really like the foam board latch. I like the fact it does dual purpose. Get some cooling airflow in there, and at the same time it allows you to grab that wing. This is the cutout where we're going to mount the interchangeable DJI O3 camera mount. So this is the camera mount itself. This is going to end up just laying in like that. See that? Cool. We're going to hot glue that. This is my DJI O3 mock-up, but at the same time I can show you this is a real DJI O3 setup. Okay, so this is the receiver, and there's a couple of mounting guidelines that you can see on the side of the print. This is easier to see when you have it in your hand because of course I print everything in white, all of this printed in all PLA, and that'll slide in just like that. Once it's slid all the way in, you'll be able to insert your pins through here. I'm not going to do that now. That'll slide into place and hold the camera from sliding out. At the same time, the camera arm itself is extendable. Okay, do you see how this is sliding in and out of that receiver mechanism? What's the reason for that? This is going to grip on this nose closeout piece. To show you, when it's installed, that piece is going to pinch just inside there, and it's going to hold the camera steady. So let's go ahead and get towards mounting some of this. I need to glue my receiver onto my top plate. It's just going to go like that. See that? Cool. So run a bead of hot glue either side here. Just like that. Receiver top plate. We'll just drop that on just like that. And that's how that should look. Okay. How do we know the exact dimensions to get this fit square in the fuselage? How do we know how much where on this nose that we want the airplane? Well, that's real easy. When I say it's real easy, I'll show you why. We can take, stand by one, these 1, 2, 3 blocks off. Here's our nose. We can take this hatch and drop it into place. See that? And then we can decide where to glue this. In doing it that way, you can make sure that this fits snug and exact. Okay? Which is kind of what you want. You want it to be, you don't want it to be a compression fit, but you want it to hold snug and in place. Again, so you can remove it just like that. But you say, I can hear you screaming, Brett, why is the leading edge not secured? Remember, That's where the camera system's going to go. And I'll show you again. Here's with our bullshit camera with our little stunt double. I'll slide this into place. And with the vent latch forward, the camera will come underneath like this, and the aft portion will slide in, and the camera will slide forward over that. That's how everything gets latched, okay? Now, nothing's glued into place. This is why this guy's flopping around and everything. So let's go ahead and do that. Let's hot glue stuff into place. And again, I will take this camera system as she is, put this in. Do not glue this into place. If you glue that into place, you've chosen poorly. I'm going to pull the camera out, just so I'm just dealing with the receiver. I will take my nose closeout. Hot glue down the sides. You can see hot glue there, hot glue there. Flip this over. Plop it in like that. Okay. Same thing if you want. I don't know, maybe this is being pedantic. Honestly, I probably wouldn't worry about this. But for the sake of gee whiz, hold that down so you get a nice solid fitting. Give that a moment to dry. While we're doing that, just for funsies, may as well go ahead and add the rudder. Rudder, obviously towards the back of the airplane. Here's the rudder. The rudder's going to go in place like this. It's going to sit in there. Make sure there's nothing in the way. What you need to do, and if there is, you get a popsicle stick. Hang on, turn around. There you go. And you want to clean out. Make sure you don't have any wires crossing there. I look pretty good. Yeah, that servo cable, it looks like from where that camera is showing, I don't know, when I'm top down on it, I don't see that servo cable being in the way, the ESC wire, but just make sure you're clear. So here we go. Show you me doing this. Drop you down so you can see. Take the rudder. I'm going to put a bead of hot glue along both those lower surfaces. See if you can, I don't like that camera. So, all right. You saw that, hot glue on both the under surfaces. This comes in like this. Obviously make sure she's going in like that. Leading edge, trailing edge, square. If you have 1, 2, 3 blocks. I love these stupid things. There you go. That's a giant utilitarian square tail. I don't know why. I dig it. So again, there's the overall airplane. Nose is still in a jig. Show you that. We got to add some flight control horns. Let me show you the camera inside there. Let's do a nose job. Pull the 1, 2, 3 blocks out. Vent forward. This comes off. Put my camera in there. It's hard to see the index marks. When you have this in your hand, it's a lot easier to see how that camera slides into the receiver. Pull the camera itself all the way forward. Put this in place. Back end presses in nicely. Camera cinches up. Let me show you that nose. I love this stupid nose on this damn airplane. I think this is cool. So you see that the camera rides at the top, the 03 air unit. And here, I'll swap it out with my beat up one. Watch this, because I know there's going to be people bitching and saying, oh, that's not a real 03, that's 3D printed version. Okay, you're right, that is. But real 03, there you go. That's in position. Have I flown it without the pin? You bet. Do you need the pin? Not necessarily. I mean, honestly, it's held in by about 8 different things. So this would go in place. This particular airplane is not designed to fly with a real camera. This is to teach a guy how to fly the airplane line of sight. So that's a real 03 mounted in there. What I love about it, that 03 gets hot. And if you look here, it sits back, it's recessed, but it has got all the airflow in the world. You know, the air is able to get through there and cool that system off, and everything stays good. So I've still got my tail jigged up. Let's go ahead and remove some of these blocks, and we'll do the underside. Probably hear the dog barking out there. Pick her up. Bring you up here. And again, have a look. There's an actual camera system in it. Yeah, you can have the antenna up or you can have the antenna down. It's entirely up to you. Tail. I mean, it's a clean airplane. Yeah. Okay, let's do some flight control horns. So for the flight control horns, I have my sets that are already made, but we'll talk about it. Let's see. Let me get the tools. So if you don't have a pair of flight control pliers, get them. I use survey stakes. I get these at the local home improvement stores. Obviously, they're just survey stakes, metal rod. Oh, I don't know. Here, I'll pull out a caliper. These guys are 1.6 millimeters in diameter, according to my non-calibrated caliper. And what I do is I measure, obviously, servo center to center to the flight control horn center. So I put a flight control horn on. These servos are centered. You see the flight control horn there on the actual elevon, and you see it on the servo, okay? The elevon is free and ready to go. Measure that distance. So I'm going to take my calipers. I'll try and do this where you can see it. Here we are. And I'll go center to center. Do not trust this. This is showing that measurement is 40 millimeters, okay? Boom, everybody loves to try and read calipers. 40 millimeters. So what I'll do is I'll take a piece of this wire, and I know that if I square the end of this wire with the end surface of this control horn, each bend will utilize 10 millimeters of material. So if I cut this to 60 millimeters in length and then centered on either end, I'll end up with 40 millimeter control horn. These are what I've done. So, to show you as they should be mounted, the flight control horns pass through, obviously, the elevon control horn. And this is as mounted. That, for your reference, as you can see, it is about the lower skin of the elevon is perhaps 2 or 3 millimeters above the upper skin of the wing center box. That is a correct takeoff trim position. I'll grab my other flight control horn. Put this into place. And everything else, so right there, this is basically, if you can see a reference between the trailing edge of the elevon and the upper surface of the fuselage skin, that'll give you your approximate takeoff trim position. And again, that's with your center of gravity on these CG marks, these circles that are cut here and here. You see those? Here's one here, and here's one here. So you do that, and you got yourself a going airplane. Obviously, standard motor rigging, setting sub trims, everything else, that applies. But that's how you build this airplane. I absolutely love it. They're a fun airplane to fly, work well with a flight controller. They work great as a RC line of sight airplane. They're simple to build. If you can go out and pick up, this is some 4-inch wide packing tape. You can throw this on the undersurface, or you can use standard packing tape. Helps to make it a little bit more rigid. You know, if you end up landing in wet grass or anything like that. I take off and land on grass all the time. Works great. If you're taking off and landing off of roads or asphalt, I'll put that up on the site on usefulaircraft.com. That's a 3D printed skid plate, for example. And as you can see, same thing, just hot glue, boom. That goes into position like that. And that'll absorb the impacts of 1,000 bad landings and 1,000,000 sins. But that's how you make it. That's the 3D printed Simple Plank. It's a great airplane. You have all the tools and all the parts and everything you need. Take it out, go for a flight. Usefulaircraft.com, follow YouTube. Let me know your thoughts. My name is Brett. Thank you for your time.